Greetings, everyone. My name is Jan Benedict, project manager of our proposed project system named DocuSync, a real-time file document system. And our goal on our project is to eliminate the administrative fatigue and data loss associated with manual file merging by building a completely decentralized offline first synchronization engine. Greetings, everyone. On this part, it covers our crucial window from week 1 to 4th week and announcing that the design and discovery phase is being completed. This phase is establishing a foundational governance of the project and finalizing what is inside of our project plan and project charter, closing the design phase and discovery phase exactly on our planned target date. Greetings, everyone. So on this part, it's about our project progress and planning. So comparing on our current progress against our experimental prototyping baseline, we are exactly on our schedule, and the design phases is being done. Finalizing our stock and UI wireframes, we have confirmed that technical and financial milestone is aligned on our feasibility study, keeping us well within our budget. Looking ahead, we have six active phases remaining, and those are iterations 1 through 4, and followed by integration and system testing. And finally, user acceptance testing and quality assurance. So on our proposed timeline, it allocates exactly 2 weeks per iteration, pushing to go live up until the 12th of October. So on our immediate next step or our next iteration will be continue on progress and will be done on July 15th. In this phase, we will initiate a Matchmaker API, build and desktop app shell, and establish our local Prisma SQLite database layer. So next slide will be reported by Paul John Palamara, and he's our lead programmer.
Thank you, Mr. Benedict. So let's now proceed to slide 4. By the way, my name is Paul G. Palamara, the lead programmer of this group. So I'll be covering our development progress and milestone. Because this reporting was strictly dedicated to the discovery and designing phases. We do not have complete coding modules, but instead our time was heavily invested drafting the software requirements, the specification, and comparing synchronization model to ensure that our architecture could operate without a central server. Here our resources plan. My allocation officially begins with a iteration 2 in July 29. So the components currently queued for the iteration are the most critical product building the sync engine core. This is where I'll be implementing the vector flux for the state tracking, log-based event sourcing, the last write wins resolver for automated merge, and the Myers-Deep algorithm to handle the delta encoding. So this is a demonstration of our system. So this is the web application, and we have here a admin panel. So let's log in first. Uh, Create local profile. Uh, what's account right here. Just approve, and then your password will be shown, and you can just copy paste here, and put the email that you just get registered. And then here we have the homepage. Uh, room. This room is for the room of the files, and this part of peers. This is where you create your room and you can join the room. Then here the config is for for the uh, conflict between two files, and also the history whenever there is a uh, file conflict. Also, we also have the matrix that doesn't work. Also, the setting also shared some appearances, theme, light mode, reset data, set factory reset, meaning clear all data, and that's for our demonstration.
Thanks, Mr. Poljan. On slide 5, we have our technical implementation overview. Similar to Poljan's report, there are no newly coded features within this specific time window, as our focus was entirely on architecture and database schema design. However, we did achieve our primary project charter deliverable, our design phase stack selection, which includes Next.js, Electron, and Expo. My specific 10% resource allocation will begin during iteration 3 on August 12. The components I will be focusing on include integrating a rich text collaborative editor using TipTap, building out the web app shell, and most importantly, setting up our HTTP polling transport layer on port 9000, which will allow our devices to communicate peer-to-peer. Next, our QA lead Sarah will discuss the core algorithmic challenges we identified during the during this design phase and how we plan to test them.
Thank you. Mga greetings, I'm Zaira Binancio, the QA lead of our system. So for our development challenges, improvements, and progress documentation, we address the primary development challenges identified in our risk register. The biggest hurdle in our decentralized offline first system is data collisions. When multiple users edit a document simultaneously without a central server, it produces divergent files that risk overwriting data upon reconnection. So what's our solution? Our solution is to resolve these conflicts using deterministic tiebreaker logic. The engine will mathematically compare vector clocks and last write twins, timestamp to determine the correct casual order. This mechanism automatically reconciled file version in the background without any manual user intervention. To ensure the data integrity and prevent delta encoding errors, we will enforce strict SHA 256 cryptographic hash checks. So, regarding changes made during development, because the discovery and design phases focus exclusively on system architecture and feasibility. So, there have been no code-based modification or technical pivots required during week 1 to 4. And now, I will pass it back to John Lloyd to quickly showcase the final evidence of our tech stack before we conclude. Thank you.
Thank you, Miss Sarah. Briefly on slide 7, this is the supporting evidence of the technology stack we finalized to support the hybrid synchronization engine Zaira just described. We chose this stack specifically because it allows us to operate without expensive cloud servers. For the web, we are using Next.js 14, React 18, and Tailwind. This acts solely as an app shell and matchmaking API using ephemeral room codes. It does not store document data. For the desktop, we are using Electron and Vite. This is the powerhouse of our system. It acts as the primary node running the local SQLite database and the HTTP sync server. For mobile, we are utilizing React Native via Expo as a flexible companion client for, for on-the-go offline editing. I'll now hand it back to Mr. Benedict to wrap up today's report. So, done greeting. So, on this part is to bring everything together. So, uh, these are the status and summary of our phases from design phase and discovery phase is now completed, and all resource allocation are set. mapped out and ready in their respective upcoming phases. So currently we're 2 out of 8 project phases complete, and saying that the phases is exactly under schedule, and next reporting window will cover the iteration 1 and our track and we are track on it, and tangible development work, specifically the Matchmaker API and database setup, will be start to appear.
And that concludes our week 4 progress report for DocuSync. Thank you all for your time and listening to our presentation of our project.